Hi, good morning guys. Welcome back from spring break. Today we are going to go ahead and start our new unit, which is going to be systems of equations. So in our table of contents, in our notebooks, we are going to go ahead and start section D. And that's going to be systems of equations. All right, so kind of like what you guys did on bell work today, systems of equations is going to be where we're going to graph a couple different lines on the same plane, and we're going to look at those intersecting points. So the first thing that we're going to talk about today are solution types. And that's going to be on page 23. So if we can, let's see, there you go, page 23, solution types. If we can go ahead and flip over to page 23. Here we go. All right. And first thing we're going to do is define what a system is and what a solution is for a system. So a system of equations is a set of equations, and that could be two or more, that are graphed on the same plane. And a solution, so a system of equations, we'll underline that. The solution is the point where the lines, because we are talking about linear system here, so the point where the lines intersect. All right, so there's a couple different things that we're going to look at today. The first one is going to be proving that your XY coordinate is the solution to your system. All right, so we're going to go ahead and get started. Here's an example. It would be something like this. So it would give you a system, and systems are usually written with these brackets. So the first system that we're going to use is going to be y equals negative 2x and y equals x plus 3. All right, so that's what a system looks like. It's just two different linear equations that you can graph on a coordinate plane. So then it's going to ask you questions like this. It's going to say something like, is the point 0, 4 a solution? And remember, a solution is where those two lines intersect. It's that coordinate point. So is this one a solution? And then we're going to have, is 2, 5 a solution? And we're going to also look at, is negative 1, 2 a solution. Now, because we are talking about linear equations here, if you have two lines, they're either going to intersect once, none, no times at all, or they can intersect infinite many times. So that's what we're going to talk about next. So we're never going to have 2 points that are going to be a solution for a system of linear equations, because your lines aren't going to intersect more than one time. Okay, so here's what we're going to do. Easiest way to do this is to start off by labeling your x and your y, and we're just going to plug our x and our y values in to our equations, and we're going to test both of them, because in order for this to work, this point right here would have to be on this line and on this line. So we have to test it out for both. All right, so our first line is y equals negative 2x, which is going to be 4 equals negative 2 times 0. All right, and we're just going to kind of solve that. So we have 4 equals 0, and that is not true. Well, if it doesn't work for one of your lines, that means it can't work for either, okay? Meaning it's not going to be the point of intersection. If that point right there is not on this line right here, it can't be the point of intersection. But we're just going to keep practicing with our math skills, so we're going to do the second one as well. So 4 equals, our x value is 0, so 0 plus 3. That's going to leave us with 4 equals 3. And again, that one doesn't work either. That tells us that this point right here is not on this line or on this line, okay? Both are x's. That tells us that this is not a solution. Okay, so we're going to do the same thing for this one. We're going to plug in our x and our y values. So y is 5, so we're going to do 5 equals negative 2 times our x value, which is 2. And we're going to end up with 5 equals negative 4. So again, this one doesn't work, which tells us this already cannot be a solution because it would have to be located on both lines to be the point of intersection. But we'll test the second one out just in case. So we have y, which is our 5. 5 equals x is 2 plus 3. Now in this case, we end up with 5 equals 5, which does work. But again, that just tells us that this point is on this line, but it's not on this line. So it can't be the point of intersection. So we have to have both of these work out in order to say that it is a solution to our system. All right, so we're going to try our last one here. So our x and our y, label those. Our y value is 2. So 2 equals negative 2, and then we're multiplying it by x, which is negative 1. That's going to end up giving us 2 equals 2. All right, so that one works, but we can't say that this is a solution yet until we test each part of our system. So our second part here, y is 2, 2 equals, and then we're going to plug in negative 1 plus 3, and that's going to give us another 2 equals 2. So if we get both check marks here, then that tells us this is a solution. Sorry, we should have written no for the second one there. All right, so that explains a little bit about what a solution looks like for your system of equations. Now you can go on to Desmos if this happened to be a calculator active question, and what you can do is you can type this in right here and then type this one in, and you can check to see which point is actually the point of intersection, and that's going to tell you which one of these is the solution. But if you don't have a calculator, it's pretty easy to figure it out as well. All right, so the second thing we're going to talk about are solution types. So we mentioned this a little bit earlier. There are 3 different types of solutions. And our 3 solution types are, you can have one solution. So what we did up here, we found just one of these to be the solution. And if you have one solution, that tells you that these lines cross literally at one point, or they are intersecting only one time. They intersect once. Okay. The second type of solution that you may have is where you have no solution. Now, if you think about what a solution means, solution tells us it's the point where the lines intersect. So if you have no solution, that means that you have 2 lines that never intersect, which means those lines would have to be parallel lines. Okay, so what do we know about parallel lines? Well, we know that they have the same slope, but different y-intercepts. So that's going to come in handy today when you do your classwork, U.5. Okay, parallel lines are going to have the same slope but different y-intercepts, and that's going to tell us that there is no solution here. They never intersect. All right, and the last type of solution we are going to see is this infinite solutions. And infinite solutions means that they are going to cross at literally every single point on that line. Well, the only way that you can have infinite solutions, or every point crossing with 2 different lines, is if they are the exact same line, which would mean they would have the exact same equation, as long as those equations are in the same format. Okay, so that kind of brings us to our next point. We always, when we're trying to decide if it's one solution, no solution, or infinite solutions, we always want to make sure that we have it in slope-intercept form. That's going to be the easiest way to tell if we have parallel lines because we can see the slope, and it's going to be the easiest way to tell if we have the exact same line. Okay, so we're going to go ahead and do a couple of examples. So our first one is going to be our one solution. And I'm going to give you a system here, and our system is going to be negative 2x plus y equals negative 4. It's our first equation there. And our second equation, negative x plus y equals 3. So right now these are in standard form. In order for us to really tell if they have no solution or infinite solutions, then we need to get them in slope-intercept form. If they don't have the same slope, that means they're not parallel. If they're not the exact same line, it means they're not infinite, which means our last option means they would only have one solution there. So first things first, we're going to change these into slope-intercept form. All right, so I'm going to start up here just to save a little bit of room. So we're going to have negative 2x plus y equals negative 4, and then we're going to have negative x plus y equals 3. We're going to change these into our y equals form. So we're going to add 2x and add 2x, and we're going to end up with y equals positive 2x minus 4. Over here, we're going to add x and add x, and we're going to end up with y equals x plus 3. So at this point, really we can take these and graph them on Desmos, or you can do a sketch, either way, or you can just kind of look at the properties. So if you remember from our last unit, parallel means they have the same exact slope, so we want to check that first. Do our two lines have the same exact slope? Well, the answer is no. This one has a slope of 2, and this one has a slope of 1. So that tells us they are not this no solution one. Then you want to check and see if it has infinite solutions. So are they the exact same? Do they have the same slope and the same y-intercept? Well, if they didn't have the same slope, then we know that they can't be the same exact line. So this one's out too. So the only one that we have left to pick is our one solution. So if we were to graph this on Desmos, which I would like for you to do just to double check, then we would have one solution. And our solution here, our solution would end up being the point where they cross, which is negative 1, 2. Right? And we can test that out on Desmos, but just by process of elimination, we could tell that this is a one solution. All right, so the second type we're going to look at is a no solution problem. And if you remember, no solution does tell us that they have to be parallel, which means we're looking for two slope-intercept equations that have the same slope. And the equations I'm going to give you now are y equals 2x plus 3 and negative 2x plus y equals negative 4. Okay, so right now if we were to look at just the coefficient of x, we would say that these do not have the same slope. But that's something we don't want to do yet because we don't have them in the same format. So in order to really choose between one solution, no solution, and infinite solutions, we still have to change them to slope-intercept form. All right, this one is good. Y equals 2x plus 3. It's already in that y equals mx plus b. This one we want to do negative 2x plus y equals negative 4. In order to get our y by itself, we're just going to add that 2x to both sides. And we're going to end up with y equals 2x minus 4. So at this stage, I'm just going to bring this one down so we can look at them on the same line. All right, so at this stage, what we're really comparing is, does it have the same slope? Does it have the same y-intercept? Or are those two lines completely different? Okay, so one solution tells us that our two lines are completely different. Now, one solution, you can have the same y-intercept. That would just mean that they cross at the y-intercept. Okay, no solution is going to tell us they're parallel, which means they have to have the same slope. So that's always what I like to look at first. Do these have the same slope? Looks like they do. We have +2 and +2. Now we can't automatically say because they have the same slope that's no solution, because infinite solutions also have the same slope. If they're the exact same line, they would just also have the same y-intercept. So these two do have the same slope but different y-intercepts, which tells us that they are just parallel, not the exact same line. All right, so if we were to graph these two, we would be looking for a solution, but again, because there's no solution, they don't cross, we don't have an answer here other than the answer, no solution. And if you'll graph these two on Desmos, you'll see that they do create those parallel lines, which we know will never ever intersect. All right, so our very last thing that we're going to talk about today is going to be our infinite solutions. So our given system here is going to be 2y plus x equals 8, and y equals -1/2 x plus 4. So again, we can't really compare these two yet because they have different formats so far. In order for us to be able to compare them, we definitely do need, oops, sorry, I didn't realize you guys couldn't see all the way over there. There we go. In order for us to be able to compare, we do have to change them to slope-intercept. So again, that's going to be our first step. All right, and we are going to make sure that we have both of these in that format. So 2y plus x equals 8, that does need to be changed. Our second one, y equals -1/2 x plus 4, that one's already in slope-intercept form, so we'll just bring that one down at the end. All right, to get our y by itself, we still always want to move our x value first. So we're going to subtract x on both sides. We end up with 2y equals -x plus 8. And if you remember that this -x really does mean a -1x. So if you want to add that 1 in there. Then we're going to divide by 2, and divide by 2 all the way across. All right. Our final answer here is going to be y equals -1/2x plus, and then 8/2 is going to give us that number 4. We're just going to bring our second one down since it was already in the correct format. Y equals -1/2 x plus 4. All right, always look at your slopes first. Our slopes are the same. Okay, that doesn't necessarily tell us it's parallel, but it does tell us that we're on the right track for that. We also have to look at our y-intercept, and because our slope and our y-intercept were the same, that tells us these lines are exactly the same, which means they're going to be right on top of each other when we graph them. That also tells us that every single point on those two lines is going to be a solution, which means you have infinite many solutions here. So our final answer for this last one, we don't have just one solution point, but we do have infinite solution points. And again, if you were to graph these, they'd graph right on top of each other. All right, so just a quick recap. When you're looking at solution types, you want to always look at the slope first. If they do not have the same slope in common, but they have the same y-intercept, it could be one solution. If they have the same slope, but different y-intercepts, it's going to give you no solution. But if they have the same slope and the same y-intercept, Toby! But if they have the same slope and the same y-intercept, that's going to be infinite many solutions. You can always graph these on Desmos just to solidify your answer. Today on IXL, you will have 2 lessons. One will be from this top part where you will be testing a solution, and the second one will be on this bottom part where you will be picking either one solution, no solution, or infinite solutions when you're given a system of equations. All right, good luck today, guys. Let me know if you have any questions.